again. So in this video I'm going to be talking about max terms and product of sums form. So I'm largely assuming that you are familiar with min terms. If you're not, I suggest you review lecture materials or read in the textbook. Min terms are covered right around page 48 in chapter 2. It's really useful stuff, so I strongly recommend you look it over. Alright, but looking at this, we've got our max term and min term table. This is from that section in the notebook. And so this is essentially just the row number for a 3 variables equation and the corresponding min terms and max terms, right? So these are all possible values of these 3 variables, right? 0, 0, 0, 0, 0, 1, 0, 1, 0, all of those. And the way you can think of the row number is if we took these 3 digits and turned it into a decimal number. So 0, 0, 0 obviously is 0, that's our row number. 1, 0, 0 here, if we convert that to a decimal number, is 4, right? Because this 1 is in the second place, so 2 squared is 4, and that gives us our row number 4. Quick way, that's just a quick way to convert between the row number and the equation here for your variables. So our min term, hopefully you're familiar with this. Our min term is an expression. It is a set of ands that tells us that we are definitely in this row, right? So if m0 is true, the expression m0 being not 1 and not 2 and not 3, then we are definitely in row 0. Because as you can see here, we have x0 is 0, x1 is, x1 is 0, x2 is 0, and x3 is 0. That is not all of those. The max term, on the other hand, is the complement of that. If the max term is true, that means we are not in this current row. So max term m0 is the expression x1 or x2 or x3. So if this evaluates to true, that means that one of these is a 1, and that means we could be in any row except for row 0. Right? So the max term is saying we are not in row 0. Same thing, m4. If m4 is true, then we are not in row 4. Okay? So the max terms are actually pretty useful because they lead us to a format that we can take from a truth table and convert to what is called product of sums form. So that is a format of a Boolean equation where we can take our truth table and turn it into a product of sums, and you'll see exactly what I mean by that in a second. Alright, and I also just want to show you how to convert between the symbol here and the expression here. So the symbol is something like M3, right? So let's take that, M3, and I'm working with latex here to render things in a nice way. I would do like the Khan Academy, write on a blackboard, but I don't have a tablet, and I'm not going to subject you to trying to read my horrible mouse drawings. So, M3. We want to take this max term, M3. We could just look at the table, but that's cheating. So what we're going to do is we want to focus on that number 3. And we want to convert that into a binary number. So you can go through and convert it, and that should be 0, 1, 1. And you want it to be the number of digits as there are variables in our equation, right? So here, since this is a 3 variable system, we are going to make a 3-digit number. Right? So 3 in binary is going to be 0, 1, 1. Next, for the max term, we want to take the complement of that number. So that gives us, the complement of 0, 1, 1 is equal to 1, 0, 0. That bar did not go over all of those numbers, unfortunately. So that small bar will represent a not for that whole thing. So the complement is 1, 0, 0, right? And now that will tell us how to evaluate each expression. We know a max term is always going to be ands, so it's going to be plus signs or sums of these values. So that first, we're going to read that number left to right. So that first one is a 1, so that means we're going to have x1 true. Then we have a 0, so we'll get the complement of x2. And the next digit is also a 0, so that means the complement of x3. So that is our expression here for the max term m3. And we can double check looking at our table here. We can see m3 is x1 or not x2 or not x3. Right? The exact same equation that we got here. So just as a reminder, we take our decimal number, turn it into binary, take the complement of that, and then we use that to evaluate whether each variable is true or false in our summation. We can do this to go the other way as well, right? So if we were given the expression not x1 or x2 or not x3, and we are told to find the max term for this, so we're going to take those values there and convert them into a binary number, right? So that binary number will be 0, 1, 0, based off of the whether or not each digit is complemented. Now we want to take the complement of that number, so we take the complement of 0, 1, 0, which is equal to 1, 0, 1. And then we want to convert that into a decimal number. So 1, 0, 1, if we convert that over, is 4 plus 1, which is 5. So that tells us that this is max term, M5. And we can double check if we look for where not x1 or x2 or not x3 is over in this table. That looks like it's M5. Cool. So hopefully that makes sense to you guys. That is a really good and convenient way to convert from the equation into the max term symbol. Alright, so let's move on to what you can do with max terms and how we design around them. So this is a truth table for just a 3-variable function. I'm not sure what the function is, but that's not really what matters. We want to take this truth table and turn it into a Boolean function. So if we were asked to get this in product of sums form, that means we are going to need to deal with max terms. So max terms will always give us the product of sums form. So the product of sums form will come from the multiplication of the max terms wherever our function is 0. Right? That's important to remember. The max terms are multiplied wherever our function is 0. So what does that look like here? That means we have m0 and m2 and m3 and m7. Right? That is our equation here. And the way that you will see this represented is by this value. So we'll have this big uppercase pi of m0, m2, m3, and m7. So that uppercase pi is how we say we are going to multiply all of these values in this series. Just like the uppercase sigma is how we say a summation, this is the product of those values. And then to further simplify things, you will often see this written out as the uppercase pi m times, 0, 2, 3, and 7. So that simplifies it a little bit more. Okay. Alright, so how do we turn this? So now we have turned our truth table into the product of max terms. So now we're going to need to turn each of these max terms into a Boolean equation. So we just went over how to do that. but just to review, we'll do this over. So 0, we're going to start there. 0 becomes, of course, the Boolean number, the binary number 0, 0, 0. We're going to take the complement of that, which gives us 1, 1, 1, which then leads us to the expression x1 or x2 or x3. Right? Next up, we want to take, so this was our expression for m0. Next, we want to look at m2. That's the next thing in our sequence here. So 2 becomes the binary number 0, 1, 0. We can take the complement 1, 0, 1. And that tells us that this equation is x1 or not x2 or x3. Okay. Next up, we're going to look at m3. So 3 becomes the binary number 0, 1, 1. Take the complement 1, 0, 0, which tells us x1 or not x2 or, sorry, I accidentally hit caps lock there, not x3. Alright, and now finally, we have m7. So 7, binary number 1, 1, 1. And 0, 0, 0 is the complement. And this tells us we are just going to be not x1. Sorry, I don't know why it keeps scrolling like that. Or not x2. I think I'm accidentally hitting the page up button or something. Or not x3. Okay? So those are our 3 equations. And now we just need to replace them into our form here. Right? So we have, finally, this truth table is represented by the Boolean function x1 or x3 and x1 or not x2. That's really obnoxious that it keeps doing that. Or x3 and x1 not x2 or not x3 and x1, sorry, not x1 or not x2 or not x3. So that is our final Boolean equation for that truth table that we saw above. And this is in product of sums form. Remember that, that's important. This is product of sums form, or POS form, of this Boolean equation, of that truth table. Now, just like minterms, where we get our sum of products, this is not guaranteed to be the minimal solution, but this is a starting place for you. And then you can work on minimizing this Boolean equation from here. Alright? So, I hope this is helpful, and then of course you can do the same thing in reverse. So if you are given the product of sums form, and you are asked to give it as the product of max terms, you're just going to need to take each of these summations and work backwards to get their corresponding max term, and then give it in this format here, where you have the product of the max terms 0, 2, 3, and 7. Alright, great. I really hope this was helpful. I hope this helps you guys understand max terms and product of sums form. Feel free to reach out if you have any questions on any of this. And yeah, thank you guys.